Science Shorts by Cody Gibson down here in Sugar Creek Bottoms. And today we're going to be looking for crinoid stems. Now most of you may not know this, but a large portion of Alabama was covered by saltwater marshes and ocean water back about 325 to 355 million years ago. It was known as the Mississippian period. And some of the remnants of those organisms that thrived in those waters can still be found in the rocks around local creeks and streams and rivers today. Whenever the rains come from the runoff, they'll flood these smaller creeks and streams, and when the water comes up, it'll deposit, it'll slow down when it comes to an opening, or if there's an obstacle, to slow down and start depositing stones. A lot of times these stones have tumbled over miles and miles and miles of creek bed, and what you'll have is a crinoid stem or another fossil cemented in the middle of a rock. And as it tumbles, it kind of wears away and breaks it down, and you'll get little impressions in the rock. The fossils themselves look like stacked nickels or dimes, or even smaller than that, but they're just little circles sometimes. You'll find them as like a little disc, or they'll be stacked together, and they look almost like a roll of coins. Crinoid stems are actually an extant species today. They belong to the subphylum Crinozoa, but they're some of the oldest life forms on the planet, and they're really super simple. They're almost like a sessile echinoderm. But there's an example right here. Sometimes you'll be walking along, and you'll be, if you got your eyes set right, you know what you're looking for, you can pick them out in amongst the rocks, just like I have, this one right here. But you can see the ridges of the crinoid stem, and on some of the larger specimens, you'll see you'll see like a little branching, almost like a segmented radius around it. And this is one of the actual fossils themselves. And in fact, here's another one that's a little less intact, but you can still see how that one's got more of like ridges on the side, and this one has a rounder structure. Okay, so I've been walking along the creek bank right here amongst the rocks, amongst the stream beds, and I've actually found a handful of crinoid stems. Now you can see that they vary in color and size and composition, and some of them are more fragmentary than others. And a lot of that has to do with the fossilization process that they undergo. But a lot of people think these are like close related to woody plants, or that their stem is some kind of tree or something, but they're actually not. They're they're called nowadays, they're called a sea lily, and they're more closely related to sea urchins or sea stars than they are anything else. But you can actually see on this one, those segments that I was talking about on the inside that branch out from the center. That's what is characteristic of these. Now these come from a part of the crinoid that is called the column, and it's almost like a stem off of a plant or something, because you had the roots at the bottom where it's anchored into the seabed, and then it branched all the way up. These were stacked all the way up, maybe a foot, 2 feet, and you had a little bulb at the end, and you could see that it had little fingers that would wave in the ocean seas. So these were actually quite flexible when they were alive back in the Mississippian. Now I've got right here, so right here I had the fossils. Here I've got an impression of a crinoid stem. And this is one that's either fallen out or it's eroded out during the fossilization process, where the waters that come through, they're slightly acidic, they're naturally acidic, and they'll start to erode the minerals that have formed the fossil impression inside the rock, leaving the rock behind. So anytime you find a hole like this, that's shaped like this with a little column in the center, that's where the crinoid stem actually was at one point in time, and it's just been eroded out. But that concludes our tour of Sugar Creek Bottoms today and our search for crinoid stems. There are several other organisms that you can sometimes find fossilized in the limestone. Back behind me, at the top of that ridge right there, you can see where the soil has eroded away, and you can actually see limestone up at the very top right there. So we know that at least at the very top of that bluff was where the floor of the ancient seabed began, and the creek has eroded it down into the limestone and has given us these fossils that we can actually pull and look at from the creek itself. So you can imagine how deep over our heads the actual ocean surface was 355 million years ago.